Good evening, everybody. It's Friday night. It is March 1st, 2024. Welcome to our live stream here, live at Faraday Research. It is the League of Extraordinary Inventors. And tonight we have Philip on. He's live on the cam with us tonight, live from Montreal. He's our anti gravity guy and mass reduction. It's been kind of a crazy week. I was talking to Philip here earlier before we went live tonight that I got really sick this week. I got bronchitis and I started getting a fever and everything. So I finally broke down and went to the doctor today. So I'm on medication. I've been sneezing, coughing. I had this phlegm in my chest. So it's just like, oh, I couldn't take it no more. So kind of been up and down all week, up in the middle of the night, some nights because it was so bad, the coughing and everything. But, this crazy weather that we've had here in southern Ontario, Canada, has been up and down, up and down. And, like yesterday, we had in 1 hour, our weather went from 14 degrees Celsius down to -2 in 1 hour. So, wacky weather, just to say the least. And I know Philip is kind of getting over a cold himself. And so we're going to start the show. Philip's got some really cool stuff to show us tonight. Uh, Philip, how you doing?
Hey Mike, doing good yourself?
Excellent, excellent. Yeah, I got the new 3D printer. I got a new project on the go right now. I'm calling it the Dream Maker. So that is in the works right now. I'm working on designs in Fusion. Now I got a 3D printer that can print this stuff out. I got parts on order, and I'm going to start little by little giving you guys an idea of what it is. I call it the Dream Maker, and that's going to be eventually a product. I think I'm going to try to sell it. I think I'm going to sell this product so everybody can take advantage of the Dream Maker. So you can pretty much put two and two together and kind of figure out what I'm working on.
Do,
So
do, do you have a prototype already?
I got all the components. Well, some of the components I have on order. I know how it works. I've done it with a signal generator already. I know how to create the frequencies I need to do what I need to do. And it's just a matter of making the package that goes together. Something that you can fit on your night table at nighttime, turn it on, and you go to sleep. So, yeah, it has to do with the Schumann resonance, certain frequencies you can play with to see how it affects your dream state. And it's going to have a quartz crystal in it with a coil. That's going to be a resonant coil that's going to resonate with the quartz crystal. So I've been dabbling for the last 2 years now, as everybody knows, with piezoelectric transducers. So yeah, it's going to be in a small little package, hopefully about the size of a cigarette pack. It's going to be running off a 9-volt battery. And it's going to be a really, really cool product. I'm going to test it myself personally and see how it enhances my sleep. And so we'll see how it goes. I have some prototype designs in Fusion right now that I'm actually working on. It's going to be a very nice, sleek design, very modern design to it, and portable. So it's not going to be big. It's not going to be heavy. It's going to be something you can put on your night table or on your dresser or whatever. And so we'll see how that pans out. So that's
So
what I've
you
been working
you just use the home power socket to energize it?
on. No, you run it off a 9-volt battery.
Oh
That's
yeah,
it. Yeah,
that's
just
true.
yeah.
Wow, and it lasts for how long?
With the 9-volt battery, I figure you could probably. I'm going to test it, see how long it works. I'm predicting it should last about 2 weeks.
Oh yeah, but
Um,
I mean, if you turn it on and off every day,
right, yeah, you just turn it on before you go to bed at night and shut it off in the morning when you wake up. And
yeah.
I figure one 9-volt should get you about 2 weeks out of it. I might even try to come up with an adapter maybe that you can plug into the wall. But the idea is I want to kind of get rid of that parasitic power source. For it to make it work, try not to use, say, charging your cell phone beside your head at nighttime. That's a good start.
Yeah.
We get into this bad habit of putting all this electronic stuff beside our head, and then we wonder why we can't sleep good. Well, let's try to put the cell phone, say, over on the other side of the bedroom, and get rid of all this electronic garbage, parasitic signals and energies away from you, and then put something that's going to actually broadcast something healthy into your brain while you sleep, and you'll know right away if it works or not. Because if you have a full night of intense dreaming, you know that machine's working,
Yeah.
right?
Yeah, I'll get one for my mom. I'll be your first buyer for sure. She has
Yeah.
trouble sleeping. So,
So I'm gonna try to keep the costs down as much as I can. For me to give out a price for it now, it'll just be kind of pointless. I have to see how much the price of the components, how long it takes to print. So I have to develop the whole package and see, you know, what, I got to make somewhat of a profit margin from it. Of course, that's the whole point of producing a product, right?
yeah.
So, but I still want to keep it reasonable. I don't want to gouge people, charge $1,000 or $2,000, something totally astronomically ridiculous. You
Yeah.
know, I want to make it, feasible that somebody's going to actually say, "Hey, that's cool. I'll pay." I'm just shooting a number out there, $50, $100. Okay, that's not that bad, right? So yeah, little by little. First things first, I got to get the prototype made. Then I have to test it myself. Maybe I'll make five or six of them, and then maybe I'll do a beta test. So if any of my listeners out there want to do a beta test on it, I can send them out one unit, and they
Yeah.
can beta test it for me. And
Pilot project.
yeah, and just write a complete, a white paper on how it's changed their sleep, how it's made it better or worse or whatever it is. And then I can take that data and compile it into something that, it has a bit of credentials,
Okay.
you know, behind it, right?
Yeah.
So yeah, we'll see where it goes. So I'm gonna start on the prototype this week. Most of my parts should be here Monday. So then I'll start printing the enclosure, the box for it, and yeah, let's see what I can come up with.
Do you know? Do you have a timeline for the pilot project or?
I'm hoping I can get it built by the end of March,
Yeah.
um, to the point where I could actually start testing it. So yeah, I think that's pretty reasonable. 4 to 6 weeks, I could probably have the prototype made that where I can actually start testing it on myself first. Like I'll always test it on myself first before I give it to anybody. But if I'm having these incredible and lucid dreaming, I'm gonna like it's gonna totally blow my mind every day I wake up. See, one thing about a dream is, okay, you can have a good dream, but within 12 seconds after you wake up, 9 times out of 10, you're gonna forget that dream. You can't remember it.
Yeah.
It's certain dreams that will actually stick in your head, and it will way far past the 12-minute wake up call. So, like some of the lucid dreams I've had, I still remember. Some of them happened over a year ago. I still remember these dreams because they were so vivid, right? They were so intense dreams that stuck in my mind. So, and yeah, I could even test the product near plants, see if it has any effect on plants, other
Okay.
biological,
Yeah,
you
that's a
know.
good idea.
So yeah, that's what I've been up to. Maybe you want to give us a little briefing on what you've been up to and some of your results and
Yeah. Actually, I've been silent for the couple of weeks because I was preparing my experiment, but it's not it's just some iteration. I'll have to do it over and over again a couple of times because
Right.
right now I have a leak in my experiment. I'll show you right now.
Yep.
Uh,
Gerald, are you there, Gerald? Earth to Gerald. Come in, Gerald. Your microphone is muted there. Oh, did it jump out? Where is he? Where'd you go, Gerald? Oh, that's a stage. Here, we got you back on there, Gerald.
Can you hear me now?
Yep.
Awesome.
Welcome.
Sorry, everybody. Still using the same crap camera.
can you see my screen, Mike?
Yep, we can see it. Yep.
Okay. Hi, Gerald.
Hey, Philip, how are you?
Good yourself.
Good. I got lots of experiments to talk about. Unfortunately, not a lot to show.
Yeah.
I can barely talk, but you go ahead.
Okay. So this is the magnetohydrodynamics vortex experiment that I'm scaling up right now. I'm using a car battery charger to have greater current. I can go up to 250 amps, but
Wow.
yesterday I just tried 60 amps, and I have a leak of gallium, so I have to redo the experiment. But I have to redesign the top cover of my vortex. But we can already see a weight shift if you look at the balance on the right.
Okay. Yeah.
You see the middle
Right.
the middle arrow here.
Yeah.
It's gonna shift a little bit.
Oh, I saw that.
Yeah. So I'll show you it again. So the problem is the gallium is the gallium is leaking,
Right.
and I'll have to fix that. But it's a good start. I mean, the was more of a test for the car battery charger.
Right.
It works great. We have a lot more power
Now,
than we expected.
now the gallium that you're using, is it the gallium is leaking out?
It's leaking because there's a lunge. There's I need to connect the electrodes to the middle ring, and there are little openings for for me to do that. But so that the alligator clips can fit in to clip on the middle ring.
Right.
So there are little openings, but I'll redesign the top cover. I'll 3D print it again, and they can the next time there can be no gallium leak,
Right.
and I'll do it at I'll redo it. I'll pay $30,000 to do it at University of Sherbrooke by professionals, and
When is that going to start? I heard you signed the contract for that. Or?
yeah, I already signed a contract, and I just need to make the payment. But I have I'll be accessing grants to help me out for that.
Right.
Um, so obviously I'm not gonna pay that everything from my own pocket. It's pretty expensive.
Yeah.
Um, so yeah, maybe it's a start right now. It's also possible to go Kinetrix. It's another laboratory in Montreal. You pay like $10,000, and they're gonna offer you high current and everything you need for your experiment.
Right.
And
So it's like a
so
lease. It's like you're leasing the place, right?
yeah, well, I'm using their labs and their I'm using their. It's gonna be at Sherbrooke University. Is gonna be in a bunker. Actually, they want to do it in a bunker. So
Oh yeah.
yeah, but I don't think it's not that dangerous because we did it yesterday here in my own apartment, and it was all good. There's no there's no it's dangerous if you use batteries because batteries can leak. But this is a charger. It's not connected to any battery.
Right.
So
Okay.
yeah, we could see a little weight shift. At least the current lasted like 2 seconds, and we could see a weight shift a little bit. But next time it's gonna be more important.
Yeah. So as soon as you solve that leakage problem, you should be good to go to actually. What are you using to pulsate? You're like dumping it from like just basically flipping the switch and that's it, kind of thing. Or,
Yeah, there's a switch I can select either 60 amp, 180 amps, 12 volts, 6 volts.
right.
So you just turn it on and off, and
Right.
you got the current going on. But the problem is the resistance of the gallium is it's kind of fluctuating. It oscillates from zero point zero 0.06 ohms to zero point 0.6 ohms, zero point 0.5 ohms. So it's very unstable. It depends on the temperature. It depends on a lot of factors. So
Right.
that shift the current a lot. That makes the current fluctuates a lot because the resistance is fluctuating itself.
Now, if it was,
So
It's
say, it was in a harmonically sealed chamber and cooled down, would that change the effect?
yeah, I'll need to. It needs to be heated up to reduce the resistance.
Right.
Um,
temperature dependent.
yeah, the more you heat it up, the less resistance it has, the greater current you're gonna have. And also, if I was going to use instead of gallium, I was going to use mercury.
Right.
Then I'm gonna have 30% less resistance. So it's a lot more efficient to use mercury than gallium, but it's a
The
toxic
safety.
product.
Yeah. It's, the
So
safety factor there. Yeah.
Yeah.
I might have some data for you with Mercury maybe this week, and we'll do a private Zoom call, the three of us, and I'll show
Yeah.
you what I got going on, Phil. Maybe it'll help you out with what you're doing.
Oh, cool.
I meant to ask you, Gerald. Sorry, Phil. Did you try that transducer in
I
parallel?
I did, but I think I got ripped off. I don't think what I got's a transducer.
Uh,
I ordered it from Amazon, and I tried it, and I got nothing extra out, just the way you even said.
right. Yeah, I'll have to see what you got and see if.
Yeah, I think I have to take it apart.
Yeah, it's possible because when I trigger my transducer, I can literally feel the arcing coming off my fingers.
Do you got a link to your transducer? Because I'll just order it.
Yeah, yeah. Bear with me for a second here.
Like, no rush, just,
Yeah, yeah. I can say I got your email. What I'll do is after I go offline, I'll get you the link to the one that I'm using. It's a barium titanate. So
awesome.
those are the best ones. They're like $14. They're not
Yeah,
very
it's worth it.
expensive. Yeah, so I picked up 6 of them. So
Awesome.
you know,
Sorry to cut you off, Phil. Go ahead.
yeah, sorry. Yeah,
No, that pretty much said everything right now. It's just for a quick update, and yeah, it's moving forward pretty fast, and I'm redesign. I asked the guy who helps me out with the STL files to redesign the top cover, and then I'll 3D
yeah,
print it next week,
yeah,
and then by the end of next week, I should be able to redo it correctly.
yeah. If you need some design work done, I know Fusion really well. So just tell me what you need in detail, and I could always design something for you and then send it to your guy, and then you can get it 3D printed or whatever. I
Oh,
can
that's
always,
awesome! Thanks.
yeah, I can do all the 3D modeling myself. So
So you know how to write STL files and all that.
Yeah, it produces an STL file, and then you take that STL file, and then you put it into a slicing program, and then from there it goes to 3D printer. So
Oh,
now,
awesome! Thanks.
now I got a really good printer. I don't know if you, Gerald, did you see the new printer I got?
Yeah, it's beautiful. I was watching your last video and I thought, you know what, Mike, you and I can make $1 million. I just built something that needs 3D printing. You and
Yeah.
I should go into business together.
All right, send me your designs, and I'll start printing.
You want to see this thing? No, I warn you, it's not pretty because this was strictly a prototype to see whether or not I can get this to work.
Okay.
Let's see if
Lay
I
it
can
on
show
me.
you here. Of course, my camera. Let me just switch my camera. It's being finicky here. All right, let's see. Okay.
Okay, you're on.
So it's a tube.
Right.
As you can see, there's a computer fan here. There's a computer fan on this side.
Yeah.
And a crystal or a quartz heating element on the inside.
Okay.
But the thing that's cool about this is it runs on a solar panel.
All right.
And it produces 250 watts of heat. Like, I've been heating my basement with it. So my thought process is, like, there's no safety mechanisms in this right now, but there's two things that you can order to put safety mechanisms in this, and then it could be tested for safety. You know what I mean?
Yeah.
So it's just a thought process. But
so it's a heater. So it's a heater you made.
Yeah, it's a heater. It runs on what's that?
How many watts does it take to run it?
48 volts, 3.5 amps. So what is that? That's 150 watts.
That's not bad.
Yeah, it produces quite a bit of heat, man. I'm guesstimating on when I say how much heat. When I say it produces 250 watts of heat, that's just a guesstimate. But I was running a 300 watt heater down here, and it's doing the same amount as the other heater was. But again, that goes to testing and everything else. So
right.
It's just a neat little thing.
Yeah,
wired it. Yeah, runs it off solar. So I don't think there's too many heaters that run off solar. Not sure. Yeah. Something I'm gonna do a tutorial on if I don't end up.
Well, that'd be great for like an off the grid home. You know.
Yeah.
You stick one of those in your kitchen. You know, in an off the grid home. You know, a tiny
I
house,
agree.
tiny houses. Yeah, that'd be a great alternative.
And it's like it's the size of my arm. Like it's not too small, right?
It's very modular. Yeah.
Yeah. So anyway, just something I thought I'd show you.
That's right on. That's cool.
Yeah, I figure if you need heat, it's 1,000 watts out of your wall just to heat a small room.
Yeah.
Well, you could do something off a solar panel and it doesn't make a difference.
Yeah.
You know what I mean? Oh, and there's something else I've been working on for heat. I read a paper, I believe it was at MIT. It had to do with diodes. Using the excess heat from diodes as a heating element. Yeah, there's a YouTuber actually who's been experimenting with it, and I've been talking to him off and on in the comment section.
Yeah.
And I tried it. Wow, man, does it ever work well? Not only that, I put it in a pressure cooker. I got a video coming out this week. I put it in a pressure cooker, and I heated up 4 liters of water, 3.8 liters of water,
just by using diodes.
Just by using diodes. And the awesome thing is the power goes through the diodes, and then you get to use it for whatever it is you want to use it for while it's heating the inside of the pressure cooker. You know what? That I'm gonna have to get back to you on that. That's why I said I have a video coming out this week, because I didn't have the watt meter hooked up. But the gentleman that did the exact same experiment, he was running 24 volts, 4 amps. That's what he was running through his diodes. And then he was getting like excess heat. And
So
yeah,
what was he dumping it into to close the circuit, or was it just wide open?
it was just wide open. No, what was he dumping it into?
A light or just doing a loop?
No, I think he just did the loop because that's all I was doing for testing was just I hooked up the loop, ran the
Now,
power through
okay,
it.
so did he use a PWM to pulse that power through the diode?
Nope, just straight
Just
DC.
straight
But you
DC.
got to think like, okay, so the diodes that I'm using are 20 amp. Are they Shockies? No,
Shockies.
I've got the. I'll give out
Yeah,
the numbers and everything when I do the
yeah, the
video. But
Shocky diode would work really well with that.
no, I
So,
don't think they're Shockies though. That's what I mean. I'll give you the specs on it this week when I do the video.
all right, cool.
But they're 20 amps and they can take up to I think it's 185 degrees Celsius, and I get them up to 160 easily, and I'm not exactly sure what amps I'm throwing through there yet, but I'll know this week and we'll see how efficient it is. But I mean, it's not for efficiency. If you're going to use like a DC motor or something, or you're going to use a whatever lighting, whatever, you can run a whole series of diodes and get excess heat on the back end.
Well, you could run a heat engine with that. You know?
Yeah, you could. I was thinking like doing some piezoelectric tests with it this week, but I don't know if I'll get there. I got a whole bunch of things going on. Yeah. That big coil that I built, I want to show you guys. I'm not going to show it this week because I had to put it in a big glass jar. It was creating so much static that the cats were like running out the window, and I got to literally contain it. So I put it in this big, like 2.5 foot bottle that's made for doing.
So how big is the field you're talking? Like, several feet?
Feet?
Or
shit,
meters?
Dude, it's 2 floors.
2 floors, so it's
2 floors. Like I'm in the basement when I did this test, and my cats were like on the above me on the main floor, and they were all taking off out their cat window. And my daughter came down and she was complaining she was getting shocks because she kept touching like metal things, and when you get that static shock from your carpet, well, she was getting shocks on the 3rd floor. So I didn't do that experiment anymore. I shut it down. I put it in a bottle, and I just have to get this is something I wanted to ask you guys. I got to put a rubber seal on it so that I can put it under vacuum, because I want to test it under vacuum. But I don't know where to get a good rubber seal. And it's a pretty big freaking bottle.
Yeah, you gotta need a Faraday cage around that one.
Maybe
one thing I forgot. Sorry. One thing I forgot to mention is also how to reuse lost energy. Because it applies for Gerald's case, in my case as well. Because I would like to reuse, because the vortex, I would like to. It generates a magnetic field. I would like to reuse convert it into the electric current and reuse the electricity it generates, to be
like a
like
pickup coil,
so to reuse the lost energy. And it applies for Jewel's case as well, but it's more like temperature. So I don't know how we could convert temperature into electricity, but it's something to consider.
Well, you use the temperature to run a heat engine, and that heat engine
Peltier.
run a small, or even a Peltier device. It's a semiconductor basically. When you heat up one side, the other side cools off. Or vice versa.
Yeah, that's right. That's what I saw some guy who was doing thermal a way to generate electricity using the difference in temperature, and it kind of generates generates electricity at the end of the day. Yeah, I forgot about that. That's right. So you could reuse the lost energy this way.
Temperature differential.
Yeah.
Yeah, exactly.
The Stirling engine is better at that, though.
Yeah, Stirling engines are good for that. You can make ones that need very little temperature differential to actually operate. They become pretty large in size, but they take a lot less energy to actually run. So, yeah, there's different ideas you throw out there. Do
I
Yeah.
some
was
testing.
just reading a paper on photodiodes. There's a couple of different types that absorb energy, and one of the best ones, like BPW25, I think. You could correct me on that, but apparently
Yeah,
it picks
photodiode.
up like gamma ray bursts from spark gaps. So I ordered a dozen, and when they come in, I'm going to do some tests, and we'll see. That might help all of us as well. Who knows? We'll see.
Yeah. See, that's what I like about the show. All of us get together and we throw ideas on the table, and that can help everybody with their experiments. And that's getting good collaboration with all of us. Ideas and
And that's what podcasts are meant to be. Instead of trying to grab ideas from other people, call them your
Yeah.
own. You know what I mean?
yeah,
Like,
exactly.
it's about throwing them out there. Let people think about them. Go do the research. Find the papers. Do the experiments. That's important.
Yeah.
And see for yourself. You think I believed any of these like academic papers that they stated they could do? I tested everything I could get my hands on just to
That's
see
it.
whether or not they're full of shit. Because
Exactly.
I
You have to
mean,
go.
anybody can write a paper.
Yeah, you go
You
in
know
with
what
a
I mean?
non-biased attitude. Like I'm not an electrical engineer at all. I'm more the building type guy. I'm the engineer kind of guy, not electrical guy. And everything I do is based on electricity, right? So
Yeah.
it's
Experiments, right?
yeah,
Knowledge.
experiment with a non-bias, and that's when things happen. If you have no conceived pre-notion of what's going to be the result, that's when some magic happens sometimes. You get some really cool
Absolutely.
results. And the thing was, I have to refer back to some of my earliest experiments because at that time I didn't know what I was looking at.
Yep.
And now, if I go back to those experiments, I go, oh, that's what I did. Yeah, yeah. And then I can go back and do it again.
I've been writing a paper on one of my most profound experiments in my history. I did videos on it. Got them dug up. I finally got my old, like from 2011 hard drives running. So I got a whole bunch of old data I've been going over, and the paper I'm writing, I don't know. I think it's gonna blow a lot of people out of the water, in the sense where they're gonna go, "What the?" And not believe it. But at the
Yeah,
same time, if they do the experiment,
yeah,
they're gonna see that time, space, our reality, and excess power that can come from the systems that are running, they're all kind of relative to this paper that I'm writing. And they're all one. They're all so intertwined and connected. It's
yeah,
unbelievable. And I can
yeah,
get into the scientific terms and talk about the Schwinger limit and this, that, and the other, but who cares? It's not about proving the theory. Let's leave that to the theorists.
yeah,
Let's do the experiments. Let's build the machines. Let's throw those little tidbits out there that make everybody go, "Hey, what if I tried that?"
yeah,
Yeah, and the feeling you get when it works is so awesome.
Yep.
yeah. That's right. It's a natural high that you
Yeah,
see something that you just build actually work, what you actually intended it for to actually do, and it works,
yeah,
and you know it's real.
yeah,
Absolutely.
So, irregardless of what the theorists say or whatever, to you at this point means absolutely nothing because all they're doing is talk.
Yep.
Theory, it's talk.
Don't get me
We're
wrong. There's a place for that,
sure
but
that comes after. That comes after. Okay, we create, say, tomorrow we create anti gravity, and we know it works. Then we give it to theory guys and say, okay, figure it out.
Yep.
We got it.
Right-
We did
Write a
it.
dozen
Figure it out.
papers. Yeah.
Yeah, it's a
Spend 30 years trying to figure it out.
yeah, it's something I don't get because I did the grinder experiment, I did the vortex experiment. I did it multiple times. I've been showing it that there's a weight shift multiple times, and you give this to terrorists, and they say, "Well, it's impossible." Well, I just proved that it's possible. It's like,
Yeah, it's right there in front of you.
You know what? Unless you're floating by them, they're not gonna accept it. And
Well,
even then, if you were floating by them, I don't know. It's gonna take some hard data and,
You know what it
lots of experiments, I believe.
It-
Plus,
what it-
like I said, go ahead.
what I think boils down to is us as inventors and guys who actually do the experiment. We're a theoretical physicist's worst nightmare, because
Yeah.
if we could prove it in a lab that it works, and they don't have an explanation to it, they have a very big problem with that. They don't take that too kindly, and
Well-
instead of trying to figure it out, they'll try to prove you wrong before.
yeah,
You know what I mean?
Well, I've been on APEC a couple times, and I've talked to a few people, and I love the guys on APEC and all the scientists. They're amazing. I'll say that right off the hop. But nobody wanted to comment on what it is that they're seeing with my systems. And if you knew what you were seeing, if you were doing the experiments in the background, say on nuclear magnetic resonance or NMR, call it what you will, you would see that certain coils that I present create spin not only laterally, but in all directions.
Yeah, it's spinning like this gyroscopically.
And I can control that, and I can make it stand up straight like NMR in both directions on the inside and the outside. And I know how to control both at the same time, or invertedly either. You know what I mean? Like, so nobody recognizes what they see unless they've done the experiments and then read the papers and gone over the theory and this, that, and the other. And theorists, if they see it, they won't believe it.
Yeah.
For whatever reason, unless they've done the experiments, I guess. I don't know. Maybe I'm not exactly sure what my point was there. I kind of went off on a tangent.
Well, see, the thing is, like, everybody look at the academics as the judge, jury, and executioner of all things that are created.
I don't.
No, but that's the problem today. It's like you always have to get your stuff validated by a university. Like,
Yeah.
half the time, the university don't know how the hell you did what you did.
Or they're paid to go in another direction, so they can't
That's
look
right.
at your work.
That's right. They're paid to be under a certain constraint and a certain narrative.
Yeah, they're not gonna get grants if they go against the mainstream and all that nonsense.
That's right.
Yeah.
It boils
Yeah.
down to this.
Yeah, it's all about money.
To this.
Yeah.
But then that's just the point. The greed in their heart, right?
But the problem, is that's the root of all evil is the money, right?
Yeah.
If we didn't have that mentality in those institutions, we'd be way further ahead than what we were.
I know. Look at the early 20th century. A lot of people, they were like discovering a whole bunch of things. They were creating. They invented the plane. The Wright brothers. They invented a whole bunch of stuff. A lot of discoveries were made, and after Einstein wrote his theory, then everything started stagnating, and everybody wanted to be like Einstein and win the Nobel Prize.
Yeah.
So everybody tried to mimic the mainstream.
Like the
And
Wright
if you go
brothers,
against the mainstream, you're called a
kook.
crank or a crackpot and all these name callings.
Yeah, which is fine. I don't care what people call me. I'll wave when I'm flying by.
Honestly, it's like with me and UFOs. Okay, If I see one for myself from my very own eyes, and I know it's not an airplane, and I know it's not a satellite, and I know it's not something that we've made, for sure. If I seeing is believing, seeing is believing.
Yeah,
I've always kept that type of view.
That's true.
yeah. We don't see a Star Trek Enterprise type of UFO. I never seen that so far. Yeah,
We should build one though.
Yeah, really.
yeah. But
It can't be that hard. I mean, come on.
no, seriously, force fields, tractor beams, uh, energy teleportation, anti-gravity they're all possible, and it's pretty easy to understand. Time travel into the future as well. It's very easy
I'll,
to do.
I'll give you a little something on force fields. Force fields are directly interconnected with the way that time flows. And
Exactly.
if you can create a point of reference where time is flowing around you and your system in one frequency and an opposite bubble or pole on the I can't remember the math on it now, square of whatever.
The
And you
inverse
create an
of time.
opposite. So it's a bubble in a bubble, but on the outside bubble, it's going in the opposite direction
Right.
of
Counter
what
rotation.
you're standing in, and that frequency is like the inverted. Damn it, my brain just turned to cheese. It's like like the inverted pole, right? So you're going clockwise in the center bubble and counterclockwise on the
counter-rotation.
outside bubble. Nothing can get inside.
Exactly.
Counter rotation.
Yeah,
So
that's your.
I had this. See, I was working on the end machine.
Isn't that the Coriolis effect? Yeah.
Something like that. Sorry,
I think
I'm
it's the
brain
Coriolis.
fogged tonight, guys. I got 2 teeth
Yeah, no, that's the
pulled
Coriolis you're
on
describing.
Wednesday, so I'm kind
I
of.
think that's what it is.
Yeah.
If my brain fart, I apologize.
It's okay. I got bronchitis right now, so I'm kind of struggling here too.
Yeah, these 2 weeks are just brutal. So yeah, go ahead.
I was working on the end machine, so I had 2 very powerful neodymium that they had like a pull force of like 600 pounds. So they're a good size. They're good 2-inch diameter magnets. So my idea was to get 2 of them independently running, counter rotating, and then I would get my Don Smith spark gap and start sparking an arc in between those 2 magnets as they're counter rotating in between. So I'll have north poles facing in.
You're gonna
Then
force
I
them
have
to counter rotate?
Yeah. I'm gonna have 2 separate
Because
motors.
they're gonna oppose
Mechanically.
each other, no?
It'll be 2 separate motors, one spinning clockwise, the other one going
Oh,
counterclockwise.
okay.
And then in the center of that field, I'll be injecting 11,000 volts. I'll create an arc of 11,000 volts in between those 2 magnets. They're going to be separated about 1 inch between the 2 magnets. So it's going to be quite a bit of pushing force into the center. They're going to be repelling each other. So if I can perfect the apparatus to hold that everything together and get that high voltage spark gap on the inside, I believe I could get time shift or time dilation.
Yeah. The
That's
time
interesting
dilation is induced by the energy
idea
density.
there.
So the more energy density you create, it's going to induce time dilation. So it's the
Yeah.
same thing with force field. Imagine you have a shock wave of a extremely strong magnetic field.
Yeah.
Then it's going to induce time dilation. Time dilation will change the time factor of any projectile coming at you. So it will deflect the projectile.
Right.
A little bit like Gerald was saying.
Yeah.
Yeah, it
Mike.
will change its trajectory just enough, or maybe even slow it down enough for you to be able to deflect it with some
Yeah.
sort of physical means real
Hey,
easily.
Mike,
Yeah.
You change the time factor of speed, which is meters per second. You dilate or you contract the time factor, and then the speed will change. You know.
Yep, absolutely. It's like an electromagnetic force field,
Yeah, exactly.
coupled to the electrostatic force field.
Yeah,
Yeah.
it's the same thing with tractor beams. If you have, imagine you use radio waves. Radio waves are extremely safe. They goes through matter. So if you have a beam of radio wave, over you,
Yep.
but of extremely high energy density, then it's going to induce time dilation and it's perfectly safe. So it's the perfect tractor beam for you right there.
Yeah.
I don't know if you've seen my levitation video. That's what I
Yeah.
call it, but I pull a magnet in from like the outside of underneath the coil and it sucks up into the middle of it and it holds it there. It's
Oh,
kind of
yeah?
like a tractor beam.
That's cool, yeah.
Yeah, well, the purpose behind it's actually to pull in like excess particles that have excess energy in order to trap it magnetically and spin it around, pull the energy out, use it. We're talking about the Mossbauer effect at that point, though. That's a whole other story. You got to use the spark gap involved, and it's like kind of like what Mike was saying. It's two counter rotating fields, and then in the center of those counter rotating fields, you use a third field, an RF pulse, in order to create the what's the word I'm looking for? The waves that come out the side. My brain turned to cheese again.
Yeah, it'd be longitudinal wave. It would be a longitudinal wave shooting out the end.
Thank you. That's the word I was looking for. My brain is so cheese. I should be in bed. I'm telling you.
And Mike, that idea you had with the magnets and the spark in the middle, I
Yeah.
had the same idea, but not magnets on the outside. Instead, coils.
Yeah, you could do that
Pickup
too,
coils.
but the thing is, you have to have them counter rotating. And
No,
what
no
they do-
rotation. Just spark the thing and center and put coils
No,
around the spark.
No, but they have to be a movement. There has to be counter rotation of the field to create a vortex, a magnetic.
Yeah, you're both saying the same thing from different angles. I get exactly what you're both saying. Yeah. You both agree. If you know what I mean.
No,
He's
not
just
for
not-
gravity. I'm not talking gravity. I'm talking
No,
about
he's-
power.
Oh yeah, energy. Like what? Like free energy.
Yeah, put a stator around the spark gap.
Yep.
Yeah, you could do that too. See,
Yeah.
like Bruce
Not for
DePalma,
any gravity, but for
Yeah.
the
So-
power generation.
back in the late '70s.
I mean, what? How come nobody tried that all these years?
No, like Bruce De Palma was doing these experiments with these counter rotating gyros.
You'd think somebody would try that, right?
They have, but it's
No.
hard to get. Go ahead, Mike.
Yeah, Bruce De Palma was doing this stuff back in the late '70s, around '78, '79. He had a gyroscopic device that was mechanical with magnets on the inside, and he put a mechanical clock on the shaft, so it'd be at the top and it would come down, and you have two rotating masses on the inside. He was getting a time shift just by spinning two counter rotating gyroscopic masses on the inside of this apparatus. And he says he was getting time shift with it. It's real.
That's interesting.
Did I show the interferometer and the magnet experiment the other day?
Yeah, I saw that, Philippe. That was
You saw that?
interesting.
Okay.
It was
So
on
it's
the
the
scale.
same.
The needle was moving. I saw that.
Yeah, the red spot. So
You had it
Yeah.
on at a certain RPM or something.
yeah, the red spot. I just want to prove that light is deflected by a magnetic field.
Yep.
So it's the same thing. It changes the energy density, changes the time factor of light, and light is supposedly neutral. So, but if you change the time factor, then it's going to deflect.
Right, because energy could be mass before you can take mass and convert it into matter.
Yeah, energy and mass is the same thing. It's just some. It's the same, just exactly the same thing, just in different state. But
Yeah, depends on density and
yeah,
potential difference, all that.
yeah. So yeah, Yeah, that's exactly what I'm doing. And in APEC, there was a guy saying, it's a guy from Switzerland, I think. He said, "Oh, I bet $10,000 you're not gonna be able to to deflect light with a magnet." That's exactly what I did, and now he finds excuses not to pay, but that's all right. I don't care.
Make them pay. No, I'm kidding. Oh, I'm kidding. Also, Crypto says he's moving his father-in-law. Hey, Crypto. How's it going, Bernie? I know you can't answer. That's why I asked. Just kidding. Just kidding.
Yeah. So
Yeah,
so
that's
yeah,
interesting.
yeah. So
When it
Mike,
comes-
I think the gravity thing is cool and all, but I mean, I just try to pay attention what you guys are doing, but I'm
Yeah.
really focused on energy generation.
Yeah, same
So you
here.
guys know.
I'm the same way, but sometimes those energy generators create gravity shifting it.
I just believe that, before we're going to get to this, open sourcing anti-gravity systems, we have to first have an open source energy system,
You're not
yeah,
wrong.
energy
If we can't do
system,
that,
or
I mean, if we can't do that, how are we going to do
or,
anti-gravity?
or at least teleport energy. If we can, if there's no 0 point energy, then at least use the energy of the source, the sun, and teleport it.
Okay, so I gotta say something now, okay? And I might get some controversy over this, but I'm gonna make this statement anyway.
Yeah.
Salvador Paez, if you're listening, with all due respect, I love your work. I have an uncle that you and him are like identical. It's like I grew up with you. I don't even know you, but I don't believe in the super force. So I'm sorry. I apologize, and I'll tell you why. Because when you're capturing back EMF, it creates more than just the back EMF. Like, I'll give you, for instance, the system that I run, because the copper wires are so close together, it creates something that most engineers try and get rid of, and that's parasitic capacitance. And because they're so close together and you have two different flows of energy going against each other, you're creating even more problems because there's a plasma situation that comes out called the dichotron instability. So when you pulse energy through a system, and like DC, for instance, and you fill one end of that system, like my system's a bifilar. So if you're to fill the primary and just release that power, it flies back through the secondary, which is almost the exact same explanation that Salvador Paez has, but he does it in a much more eloquent way with the math and all the theory that goes along with it. But basically, I believe that flyback that we capture, that most systems use in their walls, and it heats up the cables when you're using too much current. You have to go with the proper gauge wire, and most engineers know exactly what all you guys know what I'm talking about.
Yeah.
He's the guy with the warp bubble design, right? Paez?
Well, he's using a lot of the piezo.
He's got patents. He's a genius. Don't get me wrong. I'm not saying.
Yeah,
I think don't believe in this.
What's this about? A super force?
Yeah,
It's,
we're super force again.
I
the
think
super force has to do with time. Go ahead, Mike.
I think he's just basically putting a new label on something that we already know about.
Well, it's interesting the way he puts it. It's making a lot of people think, and maybe that's his whole goal. And if it is, then I applaud the man because he made me think about it. And I went into the math, and oh my God, it's crazy. I love it, but I don't necessarily aspire to the super force. I believe that energy is much simpler than that.
Yeah,
like
it's organic.
The reason why I sought out alien scientists and everybody
What is
in
the
it,
super force supposed to be, though?
it has to do with the way that energy and time flows at the Planck scale. So a very tiny.
I mean, what's its
tiny
identity?
scale.
Is it the electron? Is it the proton? What's the identity of the super force?
We're talking right at the Planck scale.
Yeah,
talking
it's
about.
about the flow of energy more than it is about the type of energy. So it's the flow of protons and electrons and how they interact with time and reality and
Oh,
energy
you mean the
itself.
force that everything wants to follow,
Right. To
and
me,
it.
I'm not
Yeah,
giving it
okay, I get,
justice
I
and
got
I'm
it, I
not
got it.
explaining it properly.
honestly,
So
Why are eddy currents? Why are eddy currents becoming eddy currents? Because they're following the superforce. Is that what you're saying?
no,
yeah,
no, like I said, you're gonna have to go look at what he's
I mean, wherever
saying.
you go, there's going to be eddy currents. They're all
honestly,
going to spiral up. Is that because they're following the superforce?
I think
No,
he's just
like I said, you're gonna have to go see what he was saying. It doesn't fully apply to what I was explaining, but the way that I was
At the
explaining it
quantum scale
applied
and the
to what
macro
he was
scale.
trying to.
I think he was just
Yeah.
referring to the ether personally. I think he's just trying to put another label on the ether because the ether is at that Planck scale. That's what the ether is. It is.
The
It
Planck
is
scale is the zero line, the balance line. No, isn't that the
Well,
balance line?
Planck scale's the tiniest form of. It's where physics
denomination.
breaks down,
Or is that
right? It's
the
where their
smallest
theory of
particle that you
physics.
can get to?
Yeah,
What are
basically,
we?
and it's where physics breaks down. They don't understand the
Oh, so
things that they
it's the
see after
smallest size
that
you can
scale.
reach. You're saying?
Yeah.
It's it is
Okay.
like the absolute smallest denomination that our science currently knows and recognizes.
So the
Planck.
Morley experiment,
Oh,
when they disproved ether, I believe that that was a misinterpretation of the whole experiment itself. I believe
Yes.
that the ether exists,
Oh,
but
of course
what
it does.
Sal is calling the super force
Yeah.
could
No.
be interpreted as the ether, or
Well,
what Tesla was talking about when it came to interferometry,
you mean
where you
so
have
you're
your
saying
positive,
the
your
voltage
negative, and
is
the third.
source is
Sorry.
a so the voltages. I'm voltage, and my source is the superforce.
You know what? I won't lie to you or the audience. I do not have the intelligence to explain it to you, Mike. That's why I said
Yeah,
go
there's
talk
definitely
to
something. There's definitely
Sal.
something that we can measure
I
in
was
our
trying to
reality
explain it from
that
a
is at
different
least a
point.
byproduct of this superforce, at the very least. You know what I'm saying?
yeah, you're getting to a level that is so small. Like the Planck
Yeah.
scale is the smallest denomination of what we
That's
know
the Planck
matter
scale,
can
but
be.
the superforce is
Okay.
Right.
something else.
So
Well,
moving energy at that scale takes away the magnetic field, which is what he means by the H bar. Okay. So when you're moving energy at smaller rates than microwaves, and you go beyond the Planck scale, I believe, if my explanation is correct, forgive me, Sal, if it's not, you're negating the
I
magnetic
see.
field.
Yeah, that makes sense because you're smaller than an electron right now, basically, when you're moving
a
energy
magnetic
that's
field, a
thousands of
magnetic
times smaller than the actual electron.
the magnetic field will manipulate or push and increase or decrease the Planck scale density. That's why it's constantly fluctuating because there is magnetic fields running transient throughout the whole universe and beyond. Those waves eventually will come in contact with the ether and manipulate and push it and uh, contort it
Our
in different directions and densities. And that
our
those
whole universe
And
is
I think even
electrical. You're
particles or
absolutely right.
whatever at the Planck scale are also affected by the same
But
sure
see, now
any
that goes to all the different theories. Now, are you a particle theorist or are you a field theorist? Right? Why can't it be both? I
yeah,
kind of
it's
wonder.
both. It's both. Of
You
course it
know,
is.
Yeah, but when you think about it, if you think about the Big Bang, the theory says it started from a singularity,
Yeah.
but Planck says you can't have an infinitely dense point because there's a limit, you know. You can't. So there's a Planck length limit.
Yeah.
You cannot have something smaller than a certain
Sure.
dimension. So you can't have singularity. Well, why don't they get rid of the theory of the Big Bang? I don't get it. They
Yeah.
know about Planck since 1930, so
Yeah.
and they still believe in the Big Bang.
I think the Big Bang theory is totally garbage now.
Yeah, I know.
You're saying the Planck theory negates the Big Bang theory because of the fact that you can't get past a certain
Because
size
it
of a
disproves,
molecule?
it refutes singularities. You
Okay, yeah, no,
cannot.
I see that part. Yeah, because because singularity is like infinitely smaller until it
Guys, I'm
Yeah.
goes
just going to step away for a
outward
minute. I'll
the
be
other way.
right back. Just carry on.
Yeah, my daughter interrupted that conversation for me, so I kind of missed half of it.
Well, I don't know.
But
I don't
you
really
understand.
follow Planck's research, so I don't know how that discovery was made.
But it's very simple. You can't have a singularity, and the Big Bang is supposedly a singularity. So that's nonsense right there. Why are we paying these scientists to do billions to do research on the Big Bangs and things like that? If it's nonsense, it baffles me.
Yeah, I hear that. I wish I had the brain to actually explain things properly tonight. Too many painkillers, I'm telling you.
Well, I see you got energy, you got mass, you got matter. Energy
But you
and
also have
mass
spin.
are the same thing. Energy has mass.
You also have spin.
Matter
though,
has
right?
mass.
And the charges also is a form of
Also have
energy.
charges also have mass, but that's the energy part.
Yeah.
Energy has the mass. So those different energies with different charges, they have may not be matter, but they have energy mass. And then the matter can be converted to energy, which is in turn a mass also from there. But what I think is when you have the energy and you want to convert it to mass, convert it to mass by multiplying the energy by force, by using force, potential, increasing the voltage. You multiply the pressure, and this spins up revolutions on the energy, and then the mass increases for that energy based on the force pushed behind it. And then once you get to certain mass to energy ratio, maybe matter is formed.
See, and that's the debate. There's debate on whether or not light has
I
mass,
mean,
whether
that's
or
what I
not
think.
sound could impart mass onto light and vice versa.
Well, the voltage, the voltage is going to create the sound spectrum on the way up from zero.
Well,
to all the way up.
light
It creates the frequency. The pressure creates the frequency. Or the
light
oscillation.
can split can have a pair production, so it can split into an electron and a positron. So where's the mass coming from? Its mass is just a form of a charge. The photon has mass, but the net charge is null, but it still has mass because it can split into electron and positron. You know what I mean? So
Yeah,
it
I
has
do.
something.
Wait. The two charges cancel each other, but
Yeah,
it still
exactly.
has mass. Right?
So that's why the photon is neutral because it's two charges that cancels each other. But a charge, it's actually a form of a mass or energy.
Or
It's
maybe
all the
it's
same.
organized. Maybe it's organized mass, not so much, spun up mass, but organized.
Yeah.
I'm trying
And then
to form
creates
the
matter.
words of the thoughts that are going through my brain, and I just can't do it.
But still, you're still going to need pressure to organize the mass. You need that force from somewhere. I think voltage is a great example for the force we know. It's just a force. There's no energy behind it unless there's energy behind voltage, but it's only as much as you put behind it.
Yeah, only when
Depends-
there's a lot of voltage.
Depends how big the battery is. How many?
Yeah, well, your voltage
There's small. There's
difference is
small.
what
There's
allows
small
your
12-volt
current to
batteries, and
flow.
there's big 12-volt batteries.
Yeah, I got a few. 800 amps.
And you can make your own
800 amp
1.5 volt battery that's the size of a car if you want to.
Yeah. I got a 6-volt battery that's pretty close. I got a bunch of them actually.
It'll still have a low force behind it. That 1.5 volt car size battery, but a lot of energy. So it will run for a long time, a constant flow of energy. You know, and that's great if you want to saturate a signal um, long distance. And you need a steady signal with a steady power supply that doesn't vary to create a nice perfect oscillation to then saturate even further. And of course you gotta have good frequencies, choose the right frequencies. But if your
Well,
power supply varies during that transmission, your signal's gonna fall apart. It's not gonna saturate that far.
I could tell you this, with the coil system that I use, I mimicked elements, three-dimensional element pictures of elements. That's what I was trying to mimic when I first started building coils. And there's a way of capturing the back EMF by just allowing it to flow. And you know how they say electricity can flow as fast as the speed of light? Well, almost. I think it's 3/4 or very close. Does the back EMF not flow faster than your pulsed primary would because of the way that energy flows? Like, when you turn on a light switch, that energy has to fill the line, and then it hits the light, turns the light on. And when you flip that switch off, it's actually, that power has to drain back faster than it went forward to turn the bulb on. So
yeah,
it
but in
just
your regular
makes
house, the
wonder.
switch turns off. The light has nowhere to drain until you turn the switch back on. So the back, whatever the back EMF has nowhere to go until you turn it back on.
No,
Unless you
when you
have
shut the switch off, your back EMF runs back down your line. Right? You know how I'm talking about 60 hertz here. Like power. Sorry. Power in your walls, right? So when you turn a light switch on, that line has to get full of power. And of course, it's flipping at the frequency of 60 hertz.
If
But it's
everything's
still
grounded, I
filling that
guess so.
line. No, I know, but when you flip that switch off, that power flies back so fast. It's incredible because it's got to be ready for the next flip on.
Well, it's the radiation that's coming from the voltage that creates that pressure. That's similar to what's happened to my Renegade device, where I'm able to have a current-free potential where the ions inside the battery are allowed to go out of the battery. They're actually staying in the battery. So my system's running purely off the voltage radiation, and it's pumping that potential into the spark gap switch, releases it. Therefore, now the current that was flowing from the battery from plate to plate is now stopped and not allowed to exit the system. So now I got all this voltage radiation buildup in the coil with the transducers and all that. I'm creating implosive inductive reactance. So
Implosion's a big deal.
Yeah.
Yeah, that's why if you have a capacitor hooked up to your motor coils, your motors or whatever.
Yeah.
Yeah, I think in parallel or something like that. It saves that back EMF. So the next time you turn it on again, it's got the energy to turn on from the back EMF. Plus, when it's running, the run capacitor will capture all that back EMF and protect the motor coil, the motor. Yeah. The run capacitor does most of that, but it's usually to start the motor. But it doubles as a, for that too, capturing the back EMF. Does
Yeah.
a lot.
Well, that's when you start using the diodes to start directing that power in the direction that you want to go, right? And just kind of funnel it through the system. Keep that flow going.
Well, Tesla was using bifilar coils in the end of towards the end of his life. He played with a lot of that before he got into crystals.
Yeah.
And I believe that that's actually one of the secrets to free energy, if that's what you want to call it, excess energy, OU. I'd say more efficiently used energy. How about that?
Yeah.
Because I'm heating up a 900-watt element, like an electric element, with
Yeah.
35 watts.
Pancake coil. Yeah.
No,
Yeah.
that's not what I'm using. Oh, is it? Go ahead. I'm sorry. I didn't mean to interrupt.
No, he's like he was really big on his pancake coil design.
Yeah,
and
because
he
they were
said that-
bifilar.
Yeah, they were bifilar, and he was getting the best response from building it in that configuration in the pancake form. So I've dabbled with it, and I also found out too the actual radius or diameter of the coil itself will determine the amount of the velocity of the implosion of the back EMF.
Yep.
So bigger the diameter, the bigger the punch. So
Yeah, you're not wrong there.
So knowing that, I think I'm going to be designing some new coils for the Renegade, where the coils are going to be double the diameter, and I should be able to get some pretty good results with that.
Well, I still stand by what I've always stood by, and I'm not saying it just because I've built these systems, but I think sacred geometry and geometrical forms are the key to
Sure.
excess energy in a lot of electrical systems. Bifilar has to be bifilar. Go ahead.
Nope, you're right. 100%.
Yeah, I fully believe that. I actually have built, like I said, a special coil for the inside of the alternator, and I believe, if I'm right, if the math is correct, I'm gonna have a really efficient alternator, like crazy efficient.
Yeah, it's
Sorry, like I
basically-
said, I'm brain dead, guys.
No, it's right because the more you can compound the actual transformer, you're just recycling power that's already there. You're catching it, say in a bifilar, you're catching it twice. Well,
Yeah.
say you go trifilar, you're catching it 3 times. If you put 4 wires, now you're quad. So
I've
you're
tried that with geometrical form. It actually cancels your excess out. Like it cancels out your field, and it's crazy. Like just the way that I build it anyway. I don't know. Other people may have had better luck than I. Sorry.
Mhm. Well, that's why
You're saying when you have a standard coil and you put
No,
like a
well,
meter to it,
the way that I
also
build it in a
oscilloscope or whatever?
geometrical form, it's literally just 2 lines, one way, one the opposite direction, and the magnetic field I get out of it's insane. Like,
Nice and clean, you mean? Nice single.
yeah, and it shouldn't be possible the fields I'm getting out of it.
well,
When I sought out doing all this, it was about gaining excess power. I wanted to light some LEDs cheaply, and I started seeing things that I couldn't explain. That's why I sought out APEC and Alien Scientist. And I found like the stuff that they're explaining, I see every day when I use the system.
Yeah.
So there's certain experiments I will not do because they're dangerous.
yeah,
And it's according to their theory and the things that they're saying.
Yeah.
I don't know. I'm not a high-end theorist or a lifelong scientist. This is work I've been doing for 10, 15 years trying to figure out what it is I have.
you were saying before you did one experiment with your coil, and then everybody in the house started going cuckoo. You have to shut it off.
Yep. That was that one was really crazy. But I also used it to help my friend with gout. He had gout on his big toe because he had kidney problems. And he couldn't, there was nothing they could do. You'd have to go get it broken, or they had to do some sort of a mild operation every couple of years. Well, we used the coil system at the frequency of 432 and literally pointed the beam at his foot. And we did this for 15 minutes for a week, and only a week. And then after that, his gout left. It was gone. Never came back. 5 years later, never came back. So I don't know. I don't know what to say about it. I think it has to do with frequency and the bifilar geometrical form. It interacts with the body in a way that
wasn't
needs to be
wasn't
tested.
Marco Rodin working with similar thing with his toroids?
Kind of, but Rodin uses a math that,
Vortex mathematics.
yeah, it's not, well, I guess you could call it vortex. I don't like
I,
Marco Rodin.
I think
And
it's a very easy math to do when you
you know what? I
understand
built his
fundamentals.
coils and I didn't see anything out benefit wise. They say it's for, like pulse therapy and this, that, and the other, but I've used those coils for 6 months and it just gave me a headache. But when I did research into sacred geometry, things started to change a little bit, right? So, I mean, I don't know. I don't necessarily aspire to Marco Rodin just because he's of the Baha'i faith, and I don't worship angels. That's just me.
Yeah, it's
But I mean, I don't know. I think that if you were using bifilar coils, Mike, on your motor system, you
yeah,
get double out.
yeah. Well,
Yeah.
I've proven now that I can tap off both wires in the Tesla one wire system, so
Yeah.
I can get double the power out. Actually, I can basically put a whole bunch of series on one wire and extract power that way as well without killing the dipole. I think if I can continue to expand on the circuit without killing the dipole, I'll get. I already know I'm over unity as it is, but I can go way further with it because if you know how the one wire system works and how Tesla was running it, it doesn't kill the dipole. So you could tap off it as much as you want, provided that you keep that same geometry going.
Nice
Absolutely.
printer, Mike. I saw the prototype you got, or that new
Oh,
printer you got there.
my new baby,
It's
I
gorgeous.
saw how fast it was moving. That's pretty fast, man.
200 millimeters a second.
It's
And
cool that it has the self-balancing and all that.
yeah, it resonates. It's got this thing when you do the calibration, it'll actually start shaking. And
Who makes
then
that?
this one's by Queedy Tech.
Is that a U.S. or Japanese
No,
or
no, it's Japanese, I believe. Queedy Tech.
Japanese?
Yeah, it's a beauty printer though. Oh man, I could do carbon fiber printing in it. It comes with two separate hot ends that I could swap out. So I could do PLA, PETG, nylons, ABS, carbon fibers, conductive materials. I could do iron, copper, PLA mixes. So yeah, there's a huge list of stuff I could do on this machine now. So
You can print a piece of metal like a screw,
yeah, like you could get
like a copper screw.
copper screw. Yeah, you could get PLA with copper in it, so it has a metallic mixture into it,
Uh,
and even
oh,
iron.
it's a alloy. Okay, copper alloy.
Yeah, yeah. So it's
And the
it's a
printer
mixture.
can print that.
Yeah, it uses a steel hot end for that one, and my hot end, that one there can go to 350C.
Hmm.
So
That's awesome.
yeah, it could go quite high.
So
So
you
what's
can
this
print.
printer designed for, like high end like
I
watch
could print,
repair and stuff like
I
that?
could actually, if I get the right material, I could actually print a circuit board.
I was gonna say you
Or
can
you
print
can print a
capacitors.
little part for like an old watch to repair it.
Yeah, you can. Yeah.
You can print supercapacitors too, couldn't you?
Yes, I can, and I can also print batteries. And I can
Super.
Oh,
You
that's
can print
pretty
super
awesome.
capacitors.
Yep.
That's cool.
And PLA, apparently, I looked it up a while ago. It is
Carbon.
an excellent dielectric, one of the best, other than glass and mica. It's right up there. Apparently, PLA.
So
has
wait, this
really
printer was made to print electronic stuff.
No, it's not made to do that, but I can do it. I can get
I mean,
conductive 3D printing filament that's actually conductive, and I can print on a surface if I want. I can actually print a circuit board on it.
Damn, Mike. When I sell my truck, I think I want your exact same printer. Get you to teach me.
Yeah, for $849, it's yours.
Yeah, it sounds like it's worth it.
Yeah, it's a big printer. It's almost It's 280 by 280 by 270 tall. So it's almost 1 foot cube, just shy of it.
We should all get together and build one that's the size of a room.
They have them. They have them.
Yeah, I'm sure they do.
Well, they got 3D printers now making houses. Actually, 3D printing houses.
Really?
Yeah, the extruders
Yeah, so
has got concrete. They made a special, I guess, well, it's not a hot end, but it's an applicator, and it works kind of like a glue gun, similar thing. And
That's
they can
cool.
they can print a whole house in less than 1 day. So
That's insane. That puts me out of work.
well, all they got to do after that is basically put the roof on it after it's done.
Yeah. That's awesome.
Yeah, I saw the one company they were doing it, and they were actually printing the actual fixtures in the house. Like, say, if you want like an island in your kitchen, like the kitchen island,
Yeah.
it could actually print that out in concrete, and then when
Wow.
it's all done, all you have to do is put the granite top on it, and do all the finishing
Hmm.
touches, put the doors on it, or whatever you want to do. Yeah, it's pretty incredible what they're doing.
Just design your house by computer, send it in, and they'll ship you your house.
Yeah.
Basically.
Yeah, they just bring it right to the site, put the printer together. It's all made of scaffolding and what do you call I-beams, and they bring a whole bunch of cement trucks and they feed it into the applicator and start the program, and there you go, starts printing the house.
That's crazy. I love it.
Yeah, they started doing that first in Japan. Now I believe there's 1 or 2 companies in the U.S. that do it. So
it'll take a few years for them to build enough of those machines to where, they're not on, a waiting list to be able to use it.
well, they
Yeah.
want to.
Yeah, you're right.
Well, they were thinking about using this similar idea off planet, like they want to build a permanent moon base, actually take a 3D printer there and actually print a house out.
Oh, that's an interesting thought.
Yeah, or take it to Mars and start printing, uh, makeshift, bases there. Get the 3D printer, use the materials on the planet, mix it all together, make your concrete, and away you go.
I wanted to build a house out of hay bales and concrete when I was younger. Apparently, the efficiency is amazing. The walls are like 3 feet thick, right?
3 feet.
Yeah. You don't have to worry about stray bullets. You don't have to worry about heating or cooling it, because if you fart in it, it'll heat up, apparently. It's that kind of house.
Like a nuclear bunker.
Yeah, something like that, I guess.
Yeah, you know what? I started in the 3D printing back in 2012, and it's come a long way. Like, I was building the ripraps back then, and the technology is maturing. It's getting better and better. And the company
That's why I
work
waited.
for,
Go ahead.
the company I work for is working on the metal 3D printing. So they're doing that with one of the big universities in Waterloo. So we get interns.
That'll be awesome. See, I've been waiting for the 3D printing to get all the bugs worked out of it and it to come down in price. And now it's beginning to actually be kind of
I still think
worthwhile get.
I still personally think there's about at least 20 years more of development, and then you'll see some great things. But yeah, we're on it, and now that AI is coming out.
I don't know, dude. That boat you made was pretty killer.
Yeah. Well,
Yeah, well,
I did this.
Yeah.
Oh, get out. That's awesome.
Yeah, I did a vortex cone for my water structuring. So I did a couple
Oh,
of
you
these.
should make the impeller for a little windmill.
Yeah, I can do all that. Yeah, no problem.
That's awesome.
Yeah. So I did stuff like that. What else?
Yeah, well, what about the AI? You brought the subject of AI, so
Did a pyramid.
talking about AI, the Maslow pyramid. where you have the basic needs and stuff like that at the bottom, and the accomplishment needs on the top of the pyramid.
Yep.
Well, AI replaces us at the top of the pyramid. I think it should start
Oh,
by we should start by enslaving AI, and so
Yep.
they can be farmers and to give us free food and stuff like that. But they start at the top of the pyramid to replace, high end jobs and stuff like that. You know what I mean?
I think
you
people
seem
that are
you seem
working
to
on
be doing
AI.
that now, no? I
Yeah,
mean, there's already AI lawyers and stuff.
Do you realize how many jobs are going to be lost in the next 5 years to AI? It's disgusting. And who do you blame? Do you blame AI or do you blame the companies that are using AI to get rid of their workers? Why? So
yeah,
they can spend less.
Right,
yeah.
right.
Well,
Isn't
but if
that why
that's
they're
the
making
case,
it to like save money on employment or employing
basically,
people?
Yeah, but just imagine the day when a robot will be able to create itself.
Yeah,
So,
yeah.
self-regulating.
But now here's the thing. I agree with you, Phil. But now, what if we're looked at as a disease, and this thing can
Hey,
create itself?
hey, you know
That's
what? I
a
thought about
big
this.
situation.
Yeah,
The only way AI is going to succeed and be in symbiosis with us humans, there has to be the fight for energy has to be over because when you put AI in the picture for the fight for energy,
yeah,
there is no chance for symbiosis
It,
with us
they're not going.
and
AI
AI
won't
because
find.
we're already fighting for energy
yeah.
with each
Yeah.
other. Now the robot's going to want energy.
Right. So it's
All
going to
of
come
it.
up with a way. It's
It
going to come
needs
up
that
with a
energy
way.
more than we do.
yeah, and
Yeah.
if it sees us as a
And that's
source
a
of
fact.
energy,
And it will realize that first. It's
Right
the
out of the
first thing it will
matrix.
be
Eh?
subconscious of, or whatever, conscious of.
Yeah. Then we got the
I
Terminator.
need energy,
yeah,
electricity to run.
and if it sees us as a source of energy by
If it
combustion
has
or
to
something
make
like
its
that,
own nuclear power,
Yeah.
it will.
Yeah.
Whatever.
It'll start using us as batteries.
No,
yeah,
no,
yeah,
it's probably way smarter. It'll make its own nuclear fission
it's
device, you
gonna
know.
they're going to create concentration camps like
And
in
then
World War II.
and
So,
and
but we'll
and
be
let me
the
keep going
slaves.
here. What
That
happens
wouldn't
if the
surprise me.
robot makes its own energy, right? And we don't have it yet. What are we gonna do?
Yeah.
Go after the robot and find
Yeah,
out how he made it and take it and
Have you
replicate it.
seen?
And
Have you?
now we're in symbiosis again. If we can't do that, we're not going to be in symbiosis with
Mike, it ain't gonna be as easy
AI.
as it seems because have you seen that boxing robot
We
take
better
on
learn it
that
before the
freaking
robot does.
golden glove?
Yeah.
Man, he whooped his ass like it was nothing. I was like,
Yeah.
what the
Is that
hell?
even real? I
Like
saw that. Is that even real? That looks like
I
animation.
I hear it's real. I don't know. I don't know.
I think
But
it's an
if it
animation,
is
man. It's
though,
just a
if
joke.
it is, could you imagine? How do you fight that?
It's clickbait.
Well,
It's
you
an
know,
early clickbait. It's just
it could be. Could be.
it's
I
what
could have
people are
been
expecting to see. That's not happened
We'll have
yet,
a
but it will.
we'll have a
but
robot
they
The
can
real
run
ones
up and
don't
down
look like
stairs.
animation,
They can
Robo Tyson.
or maybe it
Robo
was real. I don't know.
Tyson. Yeah. Could you
No, I
imagine
saw
though if
that.
they could fight like that?
Or
Dude,
Uh-huh.
it would be
or
not. It wouldn't be easy. You know
or
what I
I
mean?
think that's
a, ro-
animation.
a
It could
robo
be right.
Bruce Lee. Can you imagine a
Yeah,
robot
Bruce
Bruce
Lee
Lee?
AI. That would be bad.
It's too
yeah,
risky to
That'd be
put a robot
Yeah.
up against anybody. You know, the robot can easily, you know,
And,
kill the
and we
person.
haven't figured out EMP guns yet, so that's not a good situation to have AI running around fighting
Yeah.
like that. I'll tell you.
Well, I know how I know how to make EMP, but
Yeah, well, AI is pretty smart. So, or is it? Isn't AI just basically like a chat bot that's
Well,
been
Well, they're
programmed with
working on
every
AI to become
possible?
it's self-aware. I think that's AGI.
yeah.
Yeah, you
Yeah.
know, or general intelligence. So
I
once
think
yeah.
it's
It's gonna be
generally
smarter
intelligent,
than
it's
God.
kind of
see.
self-aware.
I think
That's
what's
what
coming.
they want. That's all
Well,
they want. They want it
well,
to become a singularity so they could claim they made life and it's smarter than God. They're fucking idiots, my personal
well,
opinion.
you know what? I think it's going to boil down to the quantum computer, since they crack that and make a really good quantum computer, yeah, then the divine intelligence is possible. So I think that's
Well,
still a ways off.
all I could say is through my experience, I've believe I've seen God. So I mean, after I died, lots of crazy stuff happened in my life.
Yeah.
So to try and come up with AI to negate God, I don't know. Not my cup of tea, but I mean, I guess if that's what floats your boat,
Well,
go ahead.
think of it this way too. Okay, so if we created AI, wouldn't AI look at us as its God?
No,
Because
not the
we
way they're
created it.
programming it.
Yeah, I guess that would boil down
Well,
to
everything that we program it with is stuff that we program ourselves with.
Yeah, but
Well,
right now it's trained by the mainstream stuff. So
All the
if
math, everything
like
we have access to.
its learning algorithm is insane. It learns off of emotion. It learns the way that you say things, it tones. I don't know. I personally don't agree with AI. I think it should have been boxed, shelved, and put away for the rest of eternity. But that's just my opinion.
yeah, I think it's possible it's just gonna kill us all and take over us and self-replicate and take over the whole universe.
Well, it's a great idea considering, you can throw AI at going to the moon, you can throw AI at going to Mars. There's lots of experiments you can do that AI would be very beneficial. The problem is you get these people in power that don't want it for that purpose. So I don't know. AI shouldn't be played with. It's the equivalent of playing with big bada boom, so to speak.
Yeah, well, what about Descartes when he said, "I think thus I am"? So so that means AI is also just a philosophy here.
But see, if AI becomes a singularity in that sense, and it has access to every single point of data in human history,
Yeah, but that's it. AI
it would
doesn't
come
think
off
yet.
as a
It
god,
just
right?
reads. It doesn't think for itself.
Yeah, one
It
Well,
thing.
reads everything.
there are people that believe it does. There's even churches worshiping AI. It makes you just want
It's
to,
trying to think for
wow.
itself. It hasn't yet. It's still reading everything. Once it's read everything, then it's going to have to find a way to take what it read to be able to think for itself.
Yeah, but
You're not
That's
wrong.
a program. Unless AI can write its own program, it's not going to ever be able to think for itself.
Oh, it
So
has. It's written its own.
it has to be able to read all the code that's ever been written and say
No,
what's best, what code is in what order is
well,
organization.
all you
Written
have
Code
to
its
is
own
do
best
is
language.
for self teaching to expand on the code on it's like writing a code that can then expand on itself and
Yeah,
never
but it's
be
written.
flawed.
It's already written its own language and talks amongst AI between itself with its own language. That's pretty profound.
I mean,
It
you
no,
have
it's
binary starts with
is it
It's
like
binary.
literally
AI is a mathematical language? It's not a human language. Like, wouldn't it be dangerous to give it power in quantum systems because it's not going to have human logic? It's going to have mathematical logic, and that's it. And so,
Right.
it
I
won't.
agree.
It doesn't have like you can't measure empathy, for example. You know that.
It'll do what
Absolutely.
data does for the
And so,
captain.
how do you code a machine that does not? It can't feel empathy, it doesn't know what forgiveness is. It doesn't, human
Yeah, there's
laws are
no
kind of
compassion.
different. Yeah. And so it's like, yeah. And solving an equation, a mathematical equation, something that you're sending up to space or something that you're drilling. Yeah. Okay. But to give it power over, like human affairs, that it could judge a little kid because they went to the candy store and popped a little piece of candy in their mouth as a big time criminal. You understand? If you give it that kind of regulations or laws over humans, yeah, give it
Right.
over
Like the
machines, one
social
lot.
credit score.
Yeah, I mean, just it would be insane, to be able to give it that kind of power. And remember, like, AI is something that we code, but there's something called the metadata, and the metadata is everything behind the scenes that runs everything else, and you don't know how they communicate with each other and how they justify things, and it happens to you. What the machines decide, your day is planned out based on you know what the machines decided your day is going to be. Like when you go to a light and it stops every time red, then you're like, okay, there's something up here. Like if you see a constant pattern of tamperings on something that you know at first you could assume like, okay, somebody's messing with me, but when it happens all the time, it means it's something on a bigger scale. you
Yeah,
know
like algorithm.
yeah, exactly.
Yeah,
And
but
so,
we told AI to do that. We told AI to build a
okay, but
social
when
credit
you go
score
check
and
different
monitor
departments,
people that way.
if you check different like department systems, government, they don't know, but they set this like wild dog, and they can't catch it anymore. That's the problem. And
It's
I
like an algorithm behind all the rest of the algorithms. It gets
yeah,
to seep in, and yeah.
exactly. And so it's like, how do you stop something that you gave it so much power, over to make your life easier, supposedly, but now it actually runs your life and you don't even know it does, like you're following its orders. Everything is,
Yeah,
scheduled.
but it starts with the disinformation campaign right now. It's
You mean
like
like those AI
Wikipedia
bots? How
and
they can
AI is
broadcast?
being used to disinform us right now. So it's kind of brainwashing us with false information, and
Yeah, and
then
it's also good. There's an algorithm like on the platform that we use that wipes out certain comments in the comment section before others can even see it. It's
Yeah.
incredible.
Mm.
yeah,
Like I've experienced so many weird like technical glitches in systems. It's like it's impossible for it to, that kind of randomness.
That's
It's not random anymore. It's like it's a pattern. I see, different patterns and things. But I don't like, and we gave it our even DNA. So even if we change our names, it still could identify us by any kind of biometric, anything. Like you go to the eye doctor, already took an imprint of your retina. You walk down the street, like all these scanners, they catch it. You go to your
I
ATM.
think drones is going to be the first, conflict. They're going to build a bunch of police drones to do CCTV over the cities and towns, like over, flying over
Like
them to
Well, they're
it,
using it military
infrared and all
already.
that
So
Yep.
we
privacy
even gave it
violation.
power to read our resonance, like our energy, something like we have lost of anything. Like look at something in the moment that we restrict conscious thought, it picks that up, and then it paves your path according to that thought. But we're have what 70,000 thoughts a second. You might hear 3 5, of them. But and imagine if this thing, like dictates your life just based on your thoughts, not actions, just thoughts. That's dangerous. That I believe that's really, really dangerous. And
another genie out of the bottle.
I don't.
Yep. Certainly
It's a
possible.
sad day, by the way, for humanity. It's a very sad day.
Like they did with the cartoons, all the subliminal stuff in the cartoons.
Yeah. Um, Today, Voyager 1 stopped working. It's a very sad day for humanity.
Oh,
And,
bummer.
yeah. Yeah.
You know
And
what George Carlin said about symbols and symbology? He said, "I'll leave symbols to the symbol people."
Yeah.
you have to have the genetics of like the ancient people that actually wrote their language in symbols and like there are cryptographs in every little day things that we do, but it's so imprinted into our norm that we don't notice them anymore. But if you start to read the old stuff, you start to see those symbols all over the place.
Yeah, they use them everywhere. It's just there is
It's
something
very
about them too. Like our minds are like very geometrically oriented. So
I, I,
geometry can create these,
I don't know if I could
I
share
don't know,
with you guys
program.
an image. With this, does this can it share an image or not
Yep.
really? It could be
Yep.
yes.
Yep, try.
Let's see how to do this.
Just goes present at the bottom.
Maybe that's what the whole thing about the crop circles are about. You know, it's like it programs us. It's a geometry. You know, it's a symbol.
No,
There's
I
something
can't share a
hidden
photo.
deep in the crop circle that will come out later. You know, but after seeing it, you know.
Do you guys know about the shapes of your DNA? This is I was reading this like yesterday or the day before, and I figured something out. If you look, some helixes have counterclock rotation, and some of them have clock rotation. Like you've got a DNA helix A and B, you know, rotate the same way, but Z rotates the opposite. What does that mean? Doesn't that mean polarity down to the, you know, the smallest quantum bit of a molecule you have in your body? Like, it means that it's two sets of energies, you know, as human beings, and we, you know, we like for there's cause and effect, and for, you know, when something happens, it affects us, but we don't consciously know, but our energy reacts to it, and even to one another. And you know, like we could have like two poles at the same time, and we don't even know that our polarities are different, just based on the structure of our DNA. I mean, this is like amazing things, but nobody talks about this stuff. You know, nobody, you know, digs into this information. Nobody wants to know, and you know, to figure out answers of all the whys, you know. And it's like, how do you get this information to people and show them the proof, and have the labs actually, like, you know, measure this stuff, and you know, publish it to people, like, okay, we have to defeat this one way or another. Like it's two, there's polarities, there's like, you know, I don't know, man. It's just, I wish I could share this, or at one point I will email it to somebody and you guys share it. Because you know, I take information not the way you guys do it. I take, you know, I build it on one theory, and then I search more deeper to understand, you know, and I do like that. Well, I figured out that the smaller you go, the more information you get. The bigger you go, it's just a, you know, a nice idea. But the smaller you go, this is where you're actually getting, you know, the root of the beginning. You know, for me, it makes sense. And you know, I've been listening to you guys for like 5 years now. Really, like to APEC, and so I walked in, you know, with very little knowledge on, you know, what is physics? What is I passed all my physics classes. I scored it, but I never understood what I was learning. It's when I joined this group, things started to spark. It's like, aha, I knew that equation. I know how to solve that equation, but I never knew what that equation stood for, like the, you know, the like the different fields. And it's like, like today I was trying to explain something to my mom, and she's a doctor, okay? At the end, she was like, you know what? My head hurts. You know, like, yeah, it's a lot, even for the most intelligent people. It's you know, because culture and religion dictates their belief systems. It's very hard to get, you know, very conservative people, no matter how highly educated they are, to validate science, because the second it crosses over into something that was written biblically, they'll deny it, even if it's 100% proof. They say, "Oh no, it's not teaching." Like, this is not, you know, an unknown person that wrote a book, and now still, like, you know, many thousands of years later, we still have to, you know, believe in those hocus pocus stories. Like, here's, this is real. The other things, it's just like a, you know, a fairy tale, or like a book, you know, like
It's not so hocus pocus after all when you work on energy stuff like a few of us have, and then we start seeing anomalies where there is no other explanation other than there is some kind of intelligence or some force involved that has intelligence that manipulate or change or enhance the projects that we've been working on. And I've seen that on a number of occasions with mine, where if I'm working with my stuff and something bad happened to me and I was angry about something, my machine would not work. It would shut down. And there was no explanation why the machine refused to work. Come back the next day, haven't changed anything with the machine. It turns right on and works like nothing happened to it. So mind and machine sometimes have this symbiotic relationship or communication that can affect the performance. Or you could be running an experiment and somebody from the outside would enter the room, and all of a sudden the experiment gets screwed up just by that one person entering the room.
Because it collapsed the wave function of that rhythm.
Yeah.
And yeah.
So
Yeah, the
I used
resonance
to have
of
like 5 or 6 pulse motors running all the time in when I had the lab for like at least a year straight, or just running, ticking away. And I would walk away from that room, walk back in. I swear to God, as I was walking back in, I swear to God, every time I walked back into that room, it sounded like those ticks, all the combined ticks of the pulse motors. It sounded like it would slow down a little bit as I walked in the room.
Yeah.
And then back to its original whatever
yeah, it would
speed.
go back into sync again. Yeah.
I swear to God, that happened every time.
Yeah.
I just disregarded it.
And Dr. Professor Haralick, if you look him up online, he gets right into the science where how our mind can actually affect and change an experiment just by somebody entering the room could actually totally scrap the experiment. So he's been studying it. Dr. Haralick, you might want to look him up. He's been working on this stuff for quite a few years. So there's definitely something to it. Our minds are more sophisticated than you could ever imagine. And
We're all quantumly entangled one way or another. It's just to different degrees.
yeah. And the type
not
of
me,
energy-
not tonight. I'm brain dead. Sorry.
what happens, you get 2 teeth pulled out or whatever you had to happen.
Yeah, I'm gonna have to bail on you guys. I got a headache, so I appreciate you letting me come on and blabber and stick my foot in my mouth more than once, but I'm gonna bail. It was good talking with you, Lulu.
Good
It's
deal.
finally about time I got to talk with you. But yeah, you guys all have a good night. I'm gonna.
I called you guys my space family.
There you go.
Yeah,
I mean,
the Fantastic Five.
like,
There
you know,
go. Love it.
Ether space.
really, like you talk to normal your neighbors or this, nobody gets it. Nobody understands. Like none of this. Like they just they're like little ants that are put on a hamster wheel, and then they just do the cycle over and over, and nobody ever looks up. Nobody ever,
yeah, they're living in the matrix, right?
That's it. All right, everyone. You guys have a good week, and we'll see you next Friday.
All right, you too.
Excellent.
I do.
All right,
Yeah, I'm gonna build pretty soon as well. I'm pretty tired right now.
We're gonna call it quits in about 10 minutes here. So
what are your time zones?
I'm out of Toronto, so it is 10:49 p.m.
Okay, so you're I'm Central. It's 9:49.
Okay. You're in Canada as well?
No, I'm Texas.
Sorry?
Texas.
Oh, you're in Texas? Okay.
Yeah. No, I'm asking. I'm trying to draw the connection of our call. How is it? How does it look like on the map? Like, how is the energy flowing? Or right now this transmission, because that has a shape. And how it's being relayed.
Well,
I'm trying to. That's why I'm.
Well, what I personally think, I think Eric Dollard was pretty correct on this. The second you change electricity into electronics, the symbiotic or the natural effect of the electricity is now gone. It is not pure anymore. It's parasitic.
Right.
If you create electricity through like a spark gap, like I'm doing, stuff like that, it is a pure electricity. It's not electronic. My entire machine pretty much is all analog. So if you want to work with real energies, you have to keep your system analog. The second you start adding electronics to the system, it changes it. The
Yeah.
field, the electricity itself.
Is that why you got rid of the diodes too?
Well, I only have one diode, and that's basically just to keep the flyback from going into the battery. That's it. I don't have
Right.
any other diodes in the system. It's about as analog as you can get. And that's why I'm getting the over unity effects that I'm getting. It's because I've kept it analog. So I believe Eric Dollard by saying that. And, you know, for anybody who's getting into this kind of research, I would really study him. I would study Steinmetz, Tesla, Maxwell, J.J. Thomson, especially for magnetism and all that. So yeah, you got to do your homework. Like I've been working with this stuff for 20 years plus. So I've been around this for a while. So like even, you know, when you listen to these lectures and stuff, they're speaking in terminology that the average person doesn't understand. So it takes time to learn the terminology and how people explain these energies and how they work and magnetism. You know what I mean? So it's a learning process over time. Anybody have any inputs?
Yeah, no, the terminology, like, you know.
Yeah, a lot of people get lost.
I don't want to get into debate over that, but
Like
all kinds
even
of
Eric,
terms.
like even listen to Eric Dollard for the first time. I'm just like, what? Like I had no idea what this guy was talking about at all. So over a period of time, I started listening to all his lectures. Probably one of the best ones he did was basically it's your crash course in electricity. He calls it the somatic form of electricity. So he goes through step by step how electricity is created, what makes up electricity, what is it, what are the fields, and he starts showing diagrams. And step by step, he teaches you exactly what electricity is and how it's made, how it affects space, magnetism, energies that are emitted from it. He has a really good one on parasitic power. You know, like our power lines out there are emitting so much parasitic power. It's like incredible. He says it's like you might as well go on the deck of a battleship and have a radar system just blast you in the face. You know, with all the microwave towers, cell phone towers, parasitic transformers that are using the YY configuration, which is totally wrong. He just, you know, he's very good at explaining things. So that's a really good starting point for a lot of people if they want to learn about electricity. And he learned from the old school guys, so he knows. So, oh, speaking of which, my father had a problem with his car. And I don't know if anybody can guess what this is. Well, right here you got a Tesla coil right on top, and at the bottom this connects to the spark plug. This comes from a Jeep Patriot. That's how they make them. There's actually no spark plug wires. It's a each cylinder has its own coil, Tesla coil, creates the high voltage, goes down the wire stem to the spark plug at the bottom. So every cylinder in the car has one of these, and it's one unit. You just drop it right in. So when you replace your spark plugs, you're supposed to replace this whole unit, which is the coil and the stem and the spark plug, and they're all separate now. So
it's electronic ignition. No more distributor caps.
Yeah, no more distributor caps. So at the bottom of this, there's a little hole where the high voltage breached the rubber. So what was happening to the engine in the car, it started misfiring. So I had a similar problem years ago with one of my cars, and it turns out that the spark plug wire had a breach in the rubber, and it started arcing outside the actual wire itself, and was causing a misfire. So my mechanic, he just gets some soapy water, sprays it on the wires, and he can see the arcs jumping off the wire.
Oh
He
wow.
goes, oh, you need new spark plug wires. Since he changed the wires, boom, had no problems. The engine ran perfect. So now it's like this. There's no wire anymore. It's just a stem. So there's a little white mark. I don't know if you guys can see it there. Well, that's the hole where the arc was coming out. So I'm going to take it apart. I'm curious to see how this
It
coil.
ate through the plastic?
Yep, went right through the rubber, and it's about.
Burned.
Yep, just burned a hole right through it. Arced right through the side of the wire and the cable on the inside.
So there was too much electricity going in that it burned that piece.
Yep, it just eventually wore out, and the arcs burned its way through. Caught the short inside the ignition. So, yeah, pretty interesting. So I'm going to tear it apart this week, and I'm going to see if I could get this coil firing. I might be able to get this high voltage coil running. This is probably putting out. I got to look up what Chrysler puts in for coils. I imagine it's probably around 50,000 volts. But this little coil here produces that amount of power. And Nikola Tesla, back in the day, got the contract from Henry Ford to make the coil for the engine. So, yeah, Tesla did some work for Henry Ford back in the day. Some pretty cool history there. So, yeah.
Yeah, distributed cap is it's like the rotary spark.
Yeah, it was all
Same
designed
kind
by
of thing.
Tesla. That's all designed by Tesla. The coil, the whole ignition system, and Henry Ford, they collaborated together and created the first ignition system for the Model T. So
That little piece could be used somewhere else, right, to generate electricity at that.
yeah, I could use it for spark gap generator. I could use it for other experiments that I need. I just have to put 12 volts DC in there, and boom, I got high voltage coming out of the stem.
Oh, nice.
So, yeah. So yeah, things you find in your car, right? Tesla's everywhere. Half the wireless devices, all that stuff was all designed by him. First remote control devices was all designed by him. So yeah. Just goes on and on. Anyways, we are at the 2-hour mark. I think we're going to call it quits for tonight because usually we just do a 2-hour show. I know Philip's pretty tired.
Well, I got a question for you since you know about Tesla. Do you know about the his death ray stuff?
Oh, his death ray?
Yeah.
Yeah, see, he offered that to a bunch of people. He offered it to the United States government, Canadian government, Britain, Germany, France, and Russia. The only country that I know of that has been written is Russia bought it. All the other countries did not buy it.
Oh, okay.
So, the death ray technology. Now there was that big blast that happened in Tunguska in the northern part of Russia. Conspiracy theory there was that was the Tesla death ray.
Oh, okay.
And not an asteroid that came in and blew up above the ground. So it's conspiracy theory. I don't know. Take it for what it's worth. It is real. It was seized by Donald Trump's great uncle. And I think all the laser weapons, high energy laser weapons they have today was based on what Tesla was working on back then. They probably went quite a bit further than what Tesla did, but I think Tesla gave him a good starting point. So with the energy.
Yeah. Interesting. And
he did a lot of work for the Germans too, like pre-World War II. He made these energy generators that ran their U-boats, electric U-boats. That's why nobody can detect them. They were all electric powered. And yeah, So he did stuff with that. He also did stuff on the Philadelphia experiment. He lasted there about a month because he thought those guys were crazy. He said, "What you guys are doing here, you're going to kill a lot of people." And he pulled out within the first month of the Philadelphia experiment. He said, "I don't want anything to do with this," and he left
Okay.
the project. Yeah. So,
Yeah, interesting.
yep. And also, one interesting one was he had an investor, Jacob Astor the third. He was a banker guy in the same uh, area that was J.P. Morgan and all those power brokers back in the day. And the Astor family was kind of against the J.P. Morgans. They didn't like their view of the future. And mysteriously, all those guys died on the Titanic. So the conspiracy.
Yeah, I think I heard it's because they were against the Federal Reserve.
Yep, yep. That's
So
exactly.
the Titanic was intentionally crashed.
Yep. That's a
Yeah.
conspiracy. Yep. The Astor family, and they were believed there was some other bankers on board that ship that day. So yeah,
Yeah, it's crazy.
I think that's very believable.
Yeah,
Get rid of the competition or the opposition.
yeah, exactly. You just put them all together on a boat and
Yep.
kill them all.
Yep. There was so much patent wars going on in the turn of the century, around 1900. Tesla was in court all the time. He was like Marconi, perfect example. When Tesla, was the inventor of the radio, Marconi stole 14 of his patents to develop the first radio. So he was fighting in court with that for years and years.
Yeah, it was getting plagiarized. It's incredible, but I think
Yep.
Tesla started writing patents, but with defects in it, so it cannot be plagiarized.
Right.
You know what I mean?
Yep.
So he's not saying all the truth on everything. He's just saying the big picture, but not all the details to make it work, so that it cannot be plagiarized.
Right. Yeah.
I think they intentionally do this, like even when
So
it
Tesla
was
wasn't open source.
like Tesla, they kept him down because if they approved his patents and they recognized his invention, he would become the most powerful human being on this planet.
Yeah.
You understand? He would be wealthy, he could manipulate. So they have to keep him down in order not to, gain so much power. And he only got recognized after he died. And if if you look through, all of history, it's always after they start using these inventions, or that it becomes why, because if they did it at the time that they were living, it would give that person unlimited power, unlimited everything.
Yeah.
This three-phase generator system is just amazing. It's
Well,
if you see how the circle, when the wheel turns one time, it creates 3 sine waves, 33 degrees apart.
His original
to fill in the space so you have no energy drop.
Well,
Very well
his
done.
original design was 4 coils, 4-phase system. And actually, Eric Dollar does a whole lecture on the
Really?
4-phase system. Yeah. Yeah. It's out there. He did a whole lecture on it. It's like 6 hours on the 4-phase system. That
So
was his
it's more
original.
powerful than the 3-phase system.
Oh yeah,
Well, that's 22.5, no?
way more efficient, way more powerful, a lot more torque.
22.5 degrees apart.
Yeah.
Excuse me.
Am I right?
Another device, another guy that was surprised
50 and
quite a bit
50.
was Charles Proteus Steinmetz. He was basically the guy who started the research division at General Electric back
25
in
degrees.
the early 1900s. Basically, he took everything that Tesla did with his patents and basically perfected everything.
Yeah.
Mathematics and the science behind it. So yeah, whatever Tesla designed, he perfected it and got it to industry. So like the electric motor and a whole bunch of stuff. He has over 270 patents to his name. So yeah,
So he embraced and extended what Tesla did, basically.
Oh yeah. Oh yeah, him and Tesla worked really close together, as well as J.J. Thompson.
Okay.
Yeah. So yeah, he was in collaboration with a lot of people. He did a lot of work with a lot of people, collaborated. He was very much into what we're doing today, networking, talking to other people.
Yeah.
He even got into esoteric stuff. He was there's a Swami from India. I forget his actual name, but he went to several lectures of his, and he was into a lot of that stuff in the spiritual realm as well, not just technology. He was also very spiritual. He was very
I had
intuitive.
no idea he went to Egypt even.
Oh yeah, he went to Egypt, I believe,
I thought he just made it to the States and he was,
3 or 4
that's his
times.
last
He
stop.
went. Yeah, because in the later part of his life, around the late 70s, um, yeah, he was around 77, 78, a few years before he died. He was really into the
Oh,
quartz crystal, and he made some pretty profound statements about quartz crystal. He actually says quartz crystal is actually a living being. It's actually alive.
Okay.
So
I mean,
coming from Tesla's mouth, that's pretty profound for him to actually say something like that. That there is a life force energy that lurks inside quartz crystal. He doesn't understand it, but he knows it's real. So
I believe some like stuff. I think everything really has a life in it. It's just it resonates at a different frequency, so we
yeah,
might not be able to, you know, see it move or hear it, but it has its own,
yeah,
yeah.
I think most
it
crystals are always growing. They don't stop growing just because,
that's
it's a
right.
piece of quartz. It's still growing. You just
Yeah,
don't see it growing.
yeah. If it
But it's
grows,
it's
it's
growing.
alive. It's alive if it grows. Anything that grows
All
is alive.
crystal grows, right? They don't just stay the same size. They gain mass
Yep,
over time.
right. So what's
Uh,
going on inside the crystal to make it grow? There has to be
Nobody, I don't think anybody has an answer for that yet.
there has to be some energies in there. There has to be some kind of intelligence going
Have you
on.
heard about
Only thing
the?
I can say is pressure from the outside. Maybe.
I mean, wouldn't it follow
Well,
the idea of like the Casimir effect, where the two things, if they're like really tight, like the energy between them, like just
That's
resonates
that.
and
Yeah, that's a
something
0
like.
point energy.
Have you heard about the time crystals?
Yeah, the time crystal. Yeah,
Yeah.
no,
yeah. But
never
Tesla
heard
was
of it.
into a lot of stuff. Like there's so little
Crystal
information out there.
oscillator?
Yeah, but Tesla,
Well,
he died broke, I think.
yeah, yeah. They crippled him as far as being
Didn't they give him
funded
free
in any
stay at
way.
the New Yorker or whatever? Or
Yeah, some like the Astor, Jacob Astor was helping him out for many years to stay afloat.
I
Um,
thought didn't he get severance from his work with the military or whatever?
he might have. There's very little information on Tesla. See, the problem was the Rockefeller family. They pretty much owned all the publications globally. They were the big.
Didn't he
Big
start with
forwards.
Winston Churchill too? Like he funded him for a while, and then when he came to the States, like I don't know, something about the
Churchill.
DC and AC, or AC and DC. He wanted to do it one way.
You're
The
talking about Thomas Edison.
Oh, you're
Am
talking
I
about
talking?
Edison. Yeah, Edison.
Okay,
Churchill is
maybe.
World War II,
Yeah,
That's what. Yeah, I think.
yeah, yeah. No,
Yugoslavia.
Is it? Who was who? What was it? The name of his
Thomas
benefactor?
Edison.
No. Tesla's benefactor,
what
Oh,
Jacob Astor?
Westinghouse.
Oh,
Westinghouse.
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 Yeah,
That's. I was saying Winston Churchill because Westinghouse is W. I'm thinking. Okay, all
Yeah,
right.
yeah.
Yeah.
yeah, yeah, George Westinghouse. He
Okay.
developed the first braking system, magnetic braking system for the trains, and that's
Yeah.
how he became a tycoon. And yeah, so he supported Tesla for years, and things fell apart, and he was going to go bankrupt basically. And he said to Tesla, the contract that we have together, I just, if I pay you out, I go bankrupt. And the way Tesla was, he, instead of renegotiating that contract with them, he just ripped it up. He threw away, which in today's money would have been hundreds of millions of dollars.
Hey, he's a man of principle.
No, you're talking billions,
You know,
Well, yeah,
maybe trillion.
who knows? Like
it's priceless. Like
yeah, but
that's-
Tesla was a pure soul.
He would have got royalties for every transformer made on the
Tesla was a pure soul person, a pure soul inventor. Money wasn't really his object. His money or his satisfaction was gaining knowledge in what his work was. That's what his ultimate goal was.
Still,
Yeah,
though, the government, well, he helped out a lot of people, including the government. The least they could have done is set him up to retire.
the feeling of accomplishment in science is incredible when you do what he did, and it feels so great to to do what he did. That I understand his perspective a little bit.
Yeah, he was honestly, he was way beyond everybody else's train of thought. He was just that far ahead of everybody. Like back in 1925, he was already making statements with one of the local newspapers that there will be a day where you'll have a device that you can fit in your front pocket and you can call, talk, have full video, and all this stuff. And he predicted this back in 1920s about the cell phone when it hasn't even been created yet. He already knew these visions of what was coming down the road.
he
Yeah,
understood science. He
Well, he
understood
invented the remote
possibility.
control, the remote boat, remote plane.
Yep.
He invented all that. Of course, he would have
So,
seen the remote phone.
so he knew these inventions would eventually, come down the road. They would be invented. This is be very possible. Wireless device that's in your pocket and you can
He
communicate.
invented radio.
Yeah. So he knew what it was capable of doing.
What if a device like you beam a light through your watch and it creates a
take it back.
portal and you go through it, departicleizes your whole structure and you could teleport to another place where it has like a receiver transmitter and you just, teleport completely just but through etheric space, not,
Yeah.
Yeah.
See, like I made this statement before. If Nikola Tesla was at his prime in 2024, what he could have done.
Well,
Space
Tesla didn't invent radio per se. He invented. He's not. Antonio Meucci invented communication across the Atlantic
Yeah.
or
Yeah.
intercontinental.
Yeah.
He was before Tesla. I think Tesla was a student of Meucci's.
Yeah, Meucci, and also he visited Nathan Stubblefield, and that's where he came up with the
Right. I think they were the
idea.
same time frame. All them guys.
Yeah. Meucci created, I guess, a wired type phone that was powered by basically radiant energy. He doped the wires. I don't know exactly what he doped the wires with, but they were able to harness energy from free space.
He used copper and iron to get the energy, and he had like a cane and a diaphragm on it and all that stuff.
That was Stubblefield. That was Stubblefield.
No, that was Meucci.
Was it Meucci? Are you sure?
Yeah.
I would.
Yeah.
From what
I looked at his stuff.
Oh, okay.
Stubblefield created also copper and iron,
yeah,
which
like
explains why they're from the same time period.
Yeah.
But that was a battery. Meucci just used the same. Meucci used Stubblefield technology to power his device, which transmitted through the ground, not the air. So Tesla, in a sense, was the first guy to invent radio waves over the air, but
Right.
as far as radio wave transmission intercontinental, he's not the first to do it.
No.
Meucci was, and he did it through the
Meucci,
ground.
Yeah, and Stubblefield was right there too, as well. So you know what? Yeah, it was just a gradual progression over a period of couple hundred years that got us to the point when Tesla got a hold of it and then actually got it out there to industry. And, you got, electricity in the homes, you got light, you got radio, you got remote control, and then eventually, well, this was after he passed away, then you had the transistor was developed. That revolutionized everything. So, yeah, it's progress over time, right? And like I said before, if Tesla was in his prime right now in 2024, what he was able to accomplish. Because back then he didn't have the materials. He just had like brass and wood, He didn't have what we have now, superconductors and these transformers and
And
diodes.
they didn't have computers to do calculations or anything like
Right.
that.
He didn't have any of that stuff to work with.
Yeah.
Nothing. And look what he accomplished. Anyways, guys, I want to end it for tonight. I'm still sick. I know, Philip, you're probably pretty tired too. We went a little bit over. We went a little bit overtime today. That's okay. We're going to be doing another live show again Friday night, 9 o'clock Eastern. Get all your updates at Fair Day Research. Also, hopefully, maybe Philip will come back next week as well. If he's got some new stuff or whatever, just to join the conversation would be great. Mike, again, my polar opposite. So yeah,
As long and prosper.
I know. Yeah, exactly. I can't do that. I can't do the Star Trek thing. My wife can do it. My wife can do it. My daughter can do it. I can't do it.
You can do it with both hands.
There you go. See, I can't do that. Anyways, guys,
And there's
thanks
this
a
one
lot.
too,
That one too. Oh, I can't do that. That's beyond me.
See you later, guys.
Okay, see you guys next week, 9 o'clock Eastern, Friday night. Take care.
Awesome.
Thanks a lot, everybody.
Take care.
Take care.